Intelligence gathering has historically constrained by the strict laws of classical physics. If you want to know what an adversary is hiding, you have to overcome distance, physical shielding, and time. If a classified file is locked inside a secure facility in a foreign capital, standard observation from thousands of miles away is impossible. Without a camera or a human asset inside that room, the information remains out of reach. By the early 1970s, intelligence agencies began investigating a radical alternative to bypass these earthly physical boundaries entirely. As traditional surveillance hit a wall of physical limits, the search for a bypass led researchers to look past Newtonian mechanics and investigate the potential of non-local phenomena. They called the process remote viewing. In formal military literature, this is defined as the acquisition and description of information blocked from ordinary perception, achieved strictly by mental means. Development of this program took place at the Stanford Research Institute in the early 1970s, led by artist and psi theorist Ingo Swann, alongside physicists Dr. Harold Puthoff and Russell Targ. To turn this concept into a replicable military tool, the SRI team sought to strip away the mysticism, establishing a rigid set of scientific protocols to observe and measure the process. This functional theory had to explain a single mechanism: how non-local information bridges the gap between a distant, unseen target and the conscious awareness of the person viewing it. Mapping this theoretical conduit required a model of reality that operated completely outside the realm of classical physics. Researchers found the structural solution they needed in a framework offered by theoretical physicist David Bohm. This illustrates Bohm's premise, dividing reality into two interacting orders. The top explicate order is our waking awareness, dominated by classical physics, particles, and analytical thought. Below lies the implicate order, a pre-physics, pre-time domain of microgenic impulses, lacking Newtonian locality. By identifying the implicate order as a repository, Bohm's framework provided the non-local mechanism theorists required to bypass the barriers of space and time. Researchers gave a specific label to this massive non-material repository, the matrix. It contains all data pertaining to everything in the physical and non-physical universe. Theorists compared this universal database to Carl Jung's collective unconscious, an underlying shared psychic network. This models the matrix as a vast 3D grid, where each dot represents a bit of universal information. Data isn't linear language. It exists as radiating gestalts, or thought balls, unified wholes tightly enfolding movement, smell, color, emotion, and texture. If the matrix indeed stores information as these raw, radiating sensory gestalts, then a viewer isn't reading a target in a traditional sense. They are attempting to physically intercept its unique energetic signature. This raises the final operational question: how does a human mind, firmly stuck in the explicate order, receive these radiating gestalts from the boundless implicate order? The theoretical bridge connecting these two realms is the signal line. This animation visualizes it as a complex energetic carrier wave. Using standard radio propagation theory as an analogy, the signal line is inductively modulated through its direct physical interaction with the informational gestalts inside the matrix. This highly condensed, modulated carrier wave then travels out of the void and crosses the boundary, conveying sensory information across vast distances to the receiver. Researchers at SRI identified a specific bottleneck. The primary difficulty of remote viewing isn't making contact with this universal signal line, but successfully interpreting the data it carries. To harness this process, a viewer must act as an antenna, decoding a universe-spanning carrier wave without allowing their conscious mind to corrupt the transmission. Part 1 introduced the premise of a quantum carrier wave, a link between the implicate and explicate orders, connecting all information across space and time. As the remote viewing program moved from experimental research into funded intelligence operations like Grillflame and Stargate, this theoretical philosophy became insufficient for the mission. The military needed more than vibes to justify the program. It required actionable intelligence built on measurable, replicable science. Researchers hypothesized that if a human is truly intercepting data from across the globe, that transmission must be a physical event. To find it, they had to look for evidence of the signal interacting with the laws of energy and matter. Dr. Edwin May, a primary scientist for Stargate, took up this mission. He moved the discourse from quantum philosophy into applied information theory to identify the exact mathematical conditions required for a successful session. Legitimizing remote viewing as a viable intelligence apparatus depended on proving that the signal was a mechanical reality, governed by physics. This concept is Shannon entropy, a mathematical measure of a system's unpredictability. After analyzing decades of session data, Dr. May identified a direct correlation between the change in thermodynamic entropy at a target site and the quality of the psychic data retrieved. Targets with a high gradient of Shannon entropy produce a strong, easily detectable signal. A rocket launch involving massive releases of energy and rapid changes in state creates a loud broadcast on the signal line. Nuclear facilities function similarly. Their highly complex informational structures and dynamic energy states make them stand out clearly against the background noise. Conversely, static, low-entropy targets, like an empty room or a barren piece of concrete, emit a faint, degraded signal that is exceptionally difficult for a viewer to lock onto. To find these broadcasts, a session monitor iterates a set of encrypted geographic coordinates. This acts as a precise tuning dial, evoking the signal line. The research suggests the signal line is physically tethered to its target, interacting with the environment and obeying underlying thermodynamic laws. If the signal is a physical transmission, we have to look at the biological apparatus the human body uses to receive it. The signal line first strikes the viewer's autonomic nervous system, or ANS, completely bypassing their conscious awareness. The ANS typically manages involuntary bodily functions like heart rate and respiration, processes that keep the organism alive without needing a single thought. Measurements show that the ANS registers the energetic impact of the transmission fractions of a second before the conscious brain even realizes a signal has been received. This autonomic bypass prevents the analytical sectors of the brain from interfering. Those conscious analytical layers are prone to fabricating data, but the ANS simply reacts to the energetic input. In this model, human biology acts as a sensitive, involuntary antenna, reacting to quantum data while the mind remains initially unaware. The final challenge is moving that data from the deep unconscious, where the ANS registers it, up into conscious thought. This is the primary bottleneck of the entire system. The data must traverse specific biological and cognitive conduits called Lyman thresholds. Humans have a strictly limited number of these conduits, and they are evolutionarily designed for survival, not for retrieving anomalous data. This makes the system incredibly fragile. Simple physical issues like hunger, illness, fatigue, or emotional distress create a massive amount of biological noise. This noise clogs the Lyman thresholds. Because the carrier wave is so faint, it cannot penetrate the interference caused by the body's own survival functions. Even when a target is broadcasting a high-entropy signal, the data can only be decoded if the human biological machine reaches a state of absolute quiet.
There is a paradox in trying to catch a faint psychic signal. The human brain is a prediction machine. The moment it detects a subtle, ambiguous piece of data, it naturally wants to fill in the blanks, overwriting the actual signal with fabricated imagination. This creates a narrow window. You have mere seconds to capture the raw data before the conscious, analytical mind activates and corrupts the feed entirely. To protect against this psychological interference, researchers at the Stanford Research Institute, led by Ingo Swann, developed a defensive protocol known as coordinate remote viewing, or CRV. The mechanical core of CRV relies on what they called a perceptual aperture. Instead of allowing a flood of unregulated psychic data, this protocol forces the information through a highly structured, staged process, deliberately widening the viewer's awareness in specific, locked intervals. Bypassing the imagination means you have to catch the psychic signal when that aperture is at its narrowest point, stopping the brain cold before a conscious thought can form. That narrowest point is stage 1. Here, the perceptual aperture is clamped down so tightly that it blocks the visual cortex from participating entirely. When the viewer receives a target coordinate, their autonomic nervous system reacts instantly. It bypasses conscious processing and translates the signal into raw kinetic energy. The physical output of this energy is the ideogram.
It is a reflexive squiggle slammed onto the paper in under 2 seconds. There is no time to think. This split-second, purely kinesthetic reflex forms the primary connection between the viewer and the invisible target's signal line. Though they look like random scratches, these instant ideograms capture the overarching physical shape, or gestalt, of the target site. A single ideogram, an unbroken mark, maps out an isolated structure, like a lone mountain peak. A double ideogram denotes a boundary or pathway, such as a long highway stretching toward the horizon. A composite ideogram represents a site built from repeating identical components, like the precise rows of a cemetery. The orientation maps the structure too. Flat expanses generate horizontal lines, while vertical marks indicate towering architecture, like the Empire State Building. Without a single visual image entering the conscious mind, the overarching structural layout of a target is recorded blindly, through pure physical reflex, in less than 2 seconds. Once the structural gestalt is securely on the page, the perceptual aperture is allowed to widen slightly, moving the viewer into stage 2. With the aperture opened, the signal's loiter time increases. The target information arrives slower, and it is allowed to linger in the viewer's consciousness. At this stage, the process relies on cognitrons, the brain's internal repository of physical and emotional memories built from past events. The faint psychic signal from the target begins to resonate with these cognitrons, triggering a series of subliminal impressions. This resonance extracts specific, raw sensory descriptors. It yields metallic sounds, acrid smells, bitter tastes, and frigid temperatures. Stage 2 converts an abstract, invisible signal into tangible physical feelings by mining the viewer's own lived experiences. But there is a rigid, critical constraint at this stage, one that dictates the success or failure of the session: the explicit prohibition of nouns. If a viewer starts recording specific objects or complex architectural terms, it indicates their analytical mind has stepped back in and overpowered the signal line. They are no longer sensing, they are guessing. If the viewer writes down the word ocean, they have failed. If they record the basic descriptors blue, cold, wet, salty, and rhythmic, they are successfully decoding the signal line. It is the core paradox of the protocol. To accurately perceive an unknown target, the viewer must systematically dismantle their own ability to name the world around them.
You know how to access the signal now, but there's a fatal flaw hidden deep inside our own biological machinery. The primary adversary in remote viewing is your own brain. Specifically, the human mind is highly uncomfortable with ambiguity. It hates incomplete data. The exact moment of failure happens in a millisecond. When the fleeting carrier wave of raw data finally crosses the threshold into your conscious awareness, it is incredibly fragile. Watch what happens in this diagram. As that clean, faint wave hits the vertical threshold of awareness, your analytical mind panics. It swarms the ambiguous data stream, desperately trying to seize control and make sense of it before it fades. The greatest threat to a session isn't failing to pick up the signal. It is the aggressive sabotage your conscious brain commits the second that signal arrives. Psychologists call this mechanism filling in the blanks.
As the faint signal dissipates, your brain grabs the first few fragmented bits of data, pulls from memory and imagination, and forcefully creates a complete picture. Let's say a viewer receives genuine sensory impressions from the signal line. They get metal, spinning, whooshing, and moving but not moving. Here you see the analytical mind prematurely fusing raw sensory bits. Seeking safety and familiarity, it instantly synthesizes inputs into a simple noun, like a swing set. But looking deeper, the actual target data represented a vastly more complex structure, a roller coaster. In coordinate remote viewing terminology, this catastrophic psychological interference has a specific name: analytical overlay, or AOL. Trusting instant visual recognition guarantees a failed session. That immediate picture is always a product of your own imagination trying to help, rather than the pure signal line. To maintain contact with the pure signal line, a viewer has to quarantine this biological instinct. The exact moment an AOL occurs in a session, the standard protocol requires temporarily halting the process to fully objectify the distraction. The viewer physically writes the offending noun or image down on the right side of their paper and explicitly labels it AOL. This physical action effectively clears the mind's cache, trapping the distraction on the page so it doesn't taint the ongoing data. This allows the viewer's aperture to reset and reacquire the pure signal. Occasionally, viewers encounter a tricky variant called an AOL/S, or analytical overlay of the signal line. This happens when the brain's flawed deduction is directly triggered by a highly specific, genuine aspect of the signal. It is almost correct, but ultimately wrong. Strict adherence to this note-taking protocol is the only way to build a functional mental firewall against your brain's constant stream of corrupted, self-generated malware. But what happens if an analytical overlay slips through? If it isn't identified, declared, and promptly cleared from the cache? The session degrades into a highly destructive psychological state known as AOL drive. AOL drive is a cognitive trap. The viewer's cognitive system becomes completely captured by the false overlay, to the extent that they falsely believe they are still operating on the genuine signal line. Look at this decision tree diagram. Once caught, the viewer's imagination takes that single initial incorrect node and rapid fires dozens of fabricated details to support the false premise. The actual target is entirely abandoned. There are specific warning signs when this happens. Indicators include repeating signals, the signal line ending in blackness, or similar AOLs in rapid succession. Once a viewer enters AOL drive, the remote viewing session experiences a total collapse. It is no longer data collection. It is pure fantasy. But underneath the protocols and the data, it is a grueling, perpetual battle against human nature itself. As a remote viewer masters their initial sensory inputs and approaches stage 3 of the protocol, the aperture widens. The fragmented impressions of a target begin to consolidate into a broad conceptual appreciation of the site. Detailed dimensional aspects emerge directly from the signal line, specific data points regarding length, height, volume, and distance. This influx of dimensional data produces an aesthetic impact on the practitioner. It triggers a physical urge to grab a pen and actively sketch the site from multiple angles, attempting to navigate the architecture of the signal line itself. Other experimental protocols discard the pen and paper entirely. Extended remote viewing utilizes audio entrainment to drop the practitioner's brainwave activity into a deep theta state. Viewers in this state report near-total dissociation from their physical bodies, experiencing vivid visualizations and bilocation phenomena. Associative remote viewing pushes the theoretical boundaries even further. By linking arbitrary physical objects to future outcomes, practitioners attempt to utilize the non-local nature of the signal line to bypass linear time and predict binary future events. Practitioners applied this associative protocol to complex real-world variables, targeting the daily fluctuations of the financial stock market. Despite theoretical frameworks involving quantum cosmology and information theory, the mainstream scientific community classifies remote viewing as a pseudoscience. The records leave us with a choice. Either we are seeing evidence of genuine quantum interconnectivity, or these results are the byproduct of an elaborate psychological artifact. To understand the scientific objection, we have to look closely at the earliest remote viewing experiments conducted at the Stanford Research Institute. Psychologists and skeptics conducted rigorous empirical evaluations of this initial data. Researchers David Marks and Richard Kamen attempted an independent replication of the SRI experiments, looking for any measurable evidence of a functioning signal line. They failed to find it. Instead, they discovered that the target matches were driven by subtle, inadvertent sensory clues left inside the raw session transcripts handed over to independent judges. These transcripts contained mundane formatting clues, things like sequential date stamps and explicit references to previous targets. Once these cues were properly redacted, independent judges were unable to match the viewer descriptions to the actual targets. Marks concluded the signal line was a subjective delusion. The perceived transmission of non-local data was actually the result of a mundane methodological error known as sensory leakage. Skeptic Michael Shermer directed his critique at the actual visual output. output of the sessions, targeting the Stage 3 sketches and ideograms. Shermer noted these initial sketches are composed of highly ambiguous lines. The brain is hardwired to seek patterns. Being so generic, they can be retroactively interpreted to match nearly any physical object, from a mountain ridge to a coffee cup handle. Researcher Ray Hyman identified another mechanical flaw within the physical targets themselves, particularly repeating video clips used to test the subjects. Hyman found that target hit rates correlated with how frequently a specific target was used. If a video clip physically degraded over time because of constant playback, it became visually distinguishable from the other options. That physical degradation created a subconscious sensory cue for the viewer. Retroactive matching and target degradation were overlapping errors, creating the appearance of a successful hit. Without controls, an unblinded remote viewing session is reduced to an exercise in cold reading and deductive reasoning. These critiques forced later applications of the program to adjust. Rigorous double-blind testing became an absolute scientific necessity. In a double-blind setup, no one in the room knows the identity of the target, neither the remote viewer nor the monitor guiding them through the session. This protocol acts as a firewall, eliminating the possibility of subconscious cueing from the monitor to the viewer. The study of the signal line provides a dual narrative. It remains a testament to the boundless theoretical potential of human consciousness and the concepts of quantum cosmology. Ultimately, the program serves as a case study in the inescapable nature of cognitive bias and the rigorous demands of the empirical scientific method.